Hi everyone, my name is Kenny Lei. Nice to meet you. This tutorial here is to teach you how to compile your R code into RMarkdown. A brief overview of this entire tutorial, what's it all about, is RMarkdown is an application that's found within RStudio and is capable of doing many things. It can form presentations using RStudio. It can help out with your app development with the help of RShiny app, but also it supports documentation. So in this tutorial today, I'm gonna focus on the documentation part. You might be wondering what's documentation, what does it mean? Documentation is like writing out your reports, writing out and sharing your code and so on within a very convenient file that you can share. And the most convenient file that many people share is through PDF files. You can write a report and share it through a PDF file, and it's very easy to read, really simple to visualize, and very worldwide to open up and check it out what the PDF is all about. Alright, so this tutorial is a very simple yet informative, really easygoing, user-friendly guide on how to compile your R code into RMarkdown. I'm going to break it down into 5 different sections. Section 1 will be just the background information, converting your R file to RMarkdown file, and actually setting up your first RMarkdown file. What does it look like? Section 2 will be surface level, just like the formatting, resources on how to really format your Markdown file and actually to knit it. But I'm also going to say render. I'm going to use these two terms interchangeably. They both mean the same thing, which is to display an output. Section 3 is my hook. I feel like section 3 is kind of like, the really cool part about R Markdown, and maybe that this cool part is the reason why you actually use R Markdown compared to writing a script using RStudio, and that's all. There's more fun and more convenience in this part, in the shortcut tips and tricks part, section 3. Section 4 is for anyone who is really new to the R coding language, then this will be very, very, very helpful in the sense I will break down how to do BoxPlot, regression line, heat maps, and so on. But if you're really familiar with the R coding language, then this part will actually show you how it will look like if you actually do report a project on like a certain data set and how it will look like while you're working on it. So check that out. And finally, section 5 is just how to save it, how to save the PDF, and how to share it. So in these 5 parts, I'm going to timestamp it in the video description below, as well as I'm going to timestamp it in this manual as well. So you can check it out and follow along and just pick and choose what information that you find most helpful for you. So that's all, and let's get on to this tutorial. Alright, so like I said before, it's an application found in RStudio. You can make a PDF, HTML, and Word document out of it. You work it through RStudio, which is this here, this home workspace I'm in. And you really don't need to install much packages, but if you do need to install a package, then you would install package RMarkdown. RMarkdown is a way that you can actually run different coding languages such as Python and SQL. So if you did not know this, in RStudio you can actually code in different languages such as C++, Python, SQL, Stan, D3, and so on the left side. But also there's more to it. You can actually code Bash, RCPP, SQL, Stan, and so on. But you can actually use R Markdown. So you're comfortable using Python, and you have a report that you use Python on, but you're worried that you just can't script it and share it. R Markdown is a solution for you. And like I said, again, the main motivation that many people use R Markdown is to actually write a report within RStudio to really really avoid just copy and pasting all the graphs and copy and pasting all the code and so on into a Word editor. It saves a lot of time and also saves a lot of effort as well. So yeah, that's all the background information, and I'm going to show you how to set it up. So I'm gonna change my screen real quick. So this is the initial screen that you start off with RStudio. Alright, so you just start off on this landing page. You start off with the console. This is where you really, start off your coding projects and so on. You can run R is default setting, so let's say that you can start straight from console, but I highly recommend you just go to a text file and just choose what file that you're working on, what language you're working on. So if you're working R script, click on that and immediately bring the console down to below, and you can just start off if you're familiar with R. So R, usually I just start with my data or find a data set. So I just load data sets, all different kinds of data sets. You can click on this button to run it, and you'll see it down below in the console. But I'm just gonna run it like that. Data, and there's so many to choose from. You can click on Tab key, whether you're using Windows or Mac. And you can find so many different data sets that is built in within R. For today's example, I'm just gonna go over Iris. So that's how I find an Iris dataset. And I click on Control Enter, and load down below in the console, as you can see. And just to make sure that I actually have this dataset loaded up, I can click on Summary. The summary function will store a summary table, and I'm choosing my object, which is Iris. So to actually run it is Control and Enter. Then you see it down below. So that's how you really start off a project. If you're working on an assignment using R, then that's the go-to default. That's how you start off. But using RMarkdown is a lot different. You gotta make sure that you have RMarkdown in your library, in your RStudio. And the most easiest way to know if you have it or not is just to see if you look on more options here. If you see RMarkdown here, then that's good. Like I said before, our Shiny app is the app development, presentations to make your PowerPoint, documents is the documentation part. This is where you start off your RMarkdown file. And you can title it whatever, and your author is your name. And I highly recommend you start with HTML. HTML is recommended because you can switch to PDF and Word output anytime. It's a lot more flexible, and it renders or inits a lot faster compared to the other two. So I will click on OK, and I have my new file. And in this new file, as you can see, that automatically has a title, author, date, and my output that we chose, which is HTML. This function here, you don't change it, you don't touch it, you don't adjust it unless if you're really advanced and you know what you need, then you don't change this. This is the function to set up your RMarkdown file, and it's also the function that helps knit your RMarkdown file. And it gives sample information where to find more information about RMarkdown and how to create an output out of it. And this is the coding block. You'll see this a lot. This is where you do all your work, and it's called cars. You can click play, then you have it here. It runs the summary table immediately. And here's just another different coding chunk that you can see. There's plot pressure, and I click play on it, and it just shows a graph of plots and pressure, which is cool. So that's how you start off. You can just only adjust these two to your liking. And of course, you can add more to it. You can get rid of this and so on. So that's the basic default RMarkdown file. For those who don't have this option, RMarkdown, I highly recommend you to make sure that you have the packages installed within it. And I mentioned in my manual, you need to do the install package. So let me get rid of this. And let me zoom in on this part here. make sure you see it nice and clear. You gotta make sure you install packages, then RMarkdown, like that. And it's highlighted in apostrophes around it, quotations around it. You gotta make sure you install this, and you gotta make sure you install a thing called tiny text as well. This is important if you want to really have a PDF file like as an output, then this is needed. This is required as well. This is where you use RMarkdown to really compile it into a PDF document. So you install these two packages. There's a different way to install it. And if you go on, let me change my windows real quick. So you go on the very top, it says tools, install packages here. Then you can install, for example, tiny text, like I said before, tiny text. Then you just install it and it's automatically there. I highly recommend this way to install packages because sometimes when you install packages through a command, it might be like really weird and you might have some trouble. So I think this is the most convenient way possible. Those tools, then click on install packages first row, and that's all. Alright, so you finally started off your RMarkdown file. It's new, it's basic, you just don't know what to do with it yet, and that's fine. But let's say that you have a R script already, you already, code something. So let's go to this example that I'm on right now. A little bit too close. Alright, that's better. So this is my R script, and it's kind of weird. You just notice that there's like this number sign plus sign next to each other, and that's fine. This is to symbolize, you specify your R code with this portion here. This will create a coding chunk that will eat everything underneath it up to the very last line with text. So this will be it. That's all it's eating, and that'll be one coding chunk. And example over here, same thing. Will eat everything to the very last line that has code on it. Then that's all. Very convenient, really easy. That's how you convert your R script to RMarkdown. And the very last part of it is the most interesting part is that you have to write down the command knit r spin and type down your file name, your current file that you're working on, knit equals false, and format, kind of make sure it's capitalized, case sensitive, gotta make sure this part is correct, and it'll create a format that's RMarkdown out of this R file. And sometimes you might say like, oh, this function does not exist within the console and so on. There might be an error. So for this command, it has to have RMarkdown, so make sure you actually install RMarkdown as well, if that's the case. So that's it. And how to make sure that you have it all set is, let me run all of this. So let me zoom out a little bit so we can see my console. Just check it out. And let me run all of this. So it ran because you can see the summary table and also you can see the plot, the pairs. And this function here shows all the possible scatter plots out of all your data set. So that's really cool. So that's all I have. And just to make sure, I can click on File, Open File, just to see if it existed. And it does exist, rscript.rmd. So I can open it up, and it's already conveniently here. And like I said before, the number sign plus sign changed into this coding block. And like I said again, it changed into this coding block. I'll eat up to everything to the very last line and add these backticks. So yeah, so that's everything on how to start off your RMarkdown file, as well as if you have an R script already. If you want to adjust it to RMarkdown, then those are the two ways. And I also mentioned there's a text file way. Just really simple, just save it as .rmd file at the very end, and that's all. So that's all for section 1. Hopefully that you learn a lot about it and you just start off your very first RMarkdown file out of it. Very nice. Alright, moving on to section 2. It'll be all about formatting net your outputs. So let me clear this part. So to find all information regarding this without my tutorial, you can go on help and you check out Markdown quick references. And you find all this information here as well that I'm about to share. Which is cool. Is like right down here you can like write down your report and like, oh, I forgot what header 1 looks like. Then you can just do like that and this and that. I certainly, with the help of the quick reference guide, I was able to produce this entire manual. So thanks to that, I'm sure that will help you as well. So header 1, header 2, header 3. Header 1 is the biggest header and header 3 is the smallest header. Links, you're able to show your links. If you're having a report going on and you want to show like, oh, this is where I learned how to make this plot inside it, right on the spot as a comment, then links is most convenient. And whoever's checking out your code can open the link. So that's cool. Images, if you want to include an image, you're more than welcome to. I included the UML image, and you might notice there's like backticks. And I mentioned backticks a lot, and I'm going to show you where it is just for a moment, so you know where it is as well. It's certainly a tough symbol to find, but you find it at the very top left corner of your keyboard. I'm sure it's on the Windows keyboard as well. You can just click on it, and it'll have this backtick for you as well, like that. So I include this because I don't want this certain portion of my manual to print it out to be evaluated. So that's why I include backticks on both sides of this. And I'm going to show you how to render this section too. So let me show you what does the image look like and what does when you finally like create an output, what it looks like. So I click on it up here right underneath your file name. Click on it, choose your options. I chose HTML. So let's see this UML logo. Here is the UML logo. So that's what happened if I don't include backticks, then be evaluated. So if you ever need to include an image for whatever reason, then that's the best way possible. It's really big because that's the size that I found it as a web address, but path to image is a way for you to adjust the image and so on of a certain logo or certain thing that you want to adjust, and we'll include the image at that certain size. But for this tutorial, I'm just going to go over the web address way. Alright, so that's all for formatting. For more information, check this out, quick reference guide. There's information and link here using RMarkdown. And this link will also include a cheat sheet as well if you click on it, which is cool. And it's certainly really helpful again. Choosing your outputs, this is something that the more novice users do if they are working through RMarkdown. But you can adjust your output to whatever output you want. So let me just show you an example real quick. So like I said, I didn't mention it, but I'm using a MacBook, so I don't have Microsoft Word, but I do have a PDF player, Adobe Acrobat. So let me adjust this to, let's imagine this is HTML first document. Then I click on it. Make sure the spelling is right as well. It will not run if it's incorrect. Then you can see the output change to HTML. But what if I adjust this to a PDF document and just click on it? Would the output be HTML again? Nope, it'll be HTML, will not be HTML, it'll be PDF document. So that's what you use to adjust your outputs. Certainly, of course, there's easier ways to do it. There's commands. If you want to include a command to render something, then you would type this out here. You would type out this command, but include your file path and this command as well. And you can find these commands in the RMarkdown package, which you should install. But for simplicity's sake and for user friendliness, the best way I would say is clicking on this button here, knit. It's easy to find. It's a really cool symbol next to it. It's next to the Finder. It's next to the settings or underneath the file name. Just click on it and it'll just run immediately. Just like that. But you won't be really neat, then do Command Shift K. So I'm going to show my keyboard again. Command Shift K. And it will render your output. For the render output, if you do Command Shift K, it's not specific, but it will go to the very last output that you generated. So my very last output was HTML. So what if I change it to PDF? I need to PDF. Then it will be PDF right here. Now when I click on Command Shift K, it will be PDF. Like that. So again, I'll go to the most recent output that you display. So that's all for rendering, that's all for formatting. It's just a basic introduction. There's a lot more to it and a lot more ways to make your PDF, your document, your report looking really, really cool and nice to share to colleagues and friends who might be interested on whatever work and information that you're sharing. Alright, so now section 3. Like I said, it's the hook, but I'm gonna mention it. It's not a definite list possible of all the shortcuts and tips and tricks, but it's certainly the most helpful one. So the very first one that I mentioned is to create these coding chunks. Backticks is a lot of work to do. When you have a very long coding assignment, you just want to just code immediately. You don't want to backtick 3 times, find the curvy braces, and just start your project right from here and just do data iris. It's a lot of work and you don't want to do that. You don't want to do that like 20 times. The best way possible is this keyboard shortcut that insert your R code block or whatever coding block you might be using, whatever language you might be using. And you can find it easily by doing the Control Option I, Control Alt I for Windows, but for Mac it's Control Option I. So I'll do Control Option I, and it'll have this. And you know that this is correct because it's a gray area, so that means it's running. It's proper. Right. So now I showed you that the output part is to output your document. So I mentioned it a lot before earlier, how to render it is Control Shift K. You might know it now, but for Windows and Linux users, same thing, Control Shift K. Alright, so these are unique cases. There's no shortcut on how to delete your R code block, unfortunately, but there's a shortcut on how to run your current R code block, which is Command Shift Enter. So let's go back to this basic RMarkdown document, and I just want to see a summary table, cars. So what I do is Command Shift Enter. Command Shift Enter for Mac users, and for Windows users, same thing, Control Shift Enter. So Command Shift and Lastly, enter. And it'll show this summary table. It'll display right underneath your R code block. And to run all the coding blocks possible in your RMarkdown file, then it's Control Alt R for Windows user, but for Mac users it's Command Option R. So let's check this out. This is a very small report, but let's check this out. Control Option R, and I ran this summary table, but also ran this plot as well. So that's all you need to know on the keyboard shortcuts. Altering your R code blocks. This is definitely unique, and I'm going to show you different scenarios that you might need it. The very first one is the eval equal false. Eval equal false is a serial code, but do not evaluate it. So let's go down here for this example. For examples, if you're working on a coding project and you install packages, but you don't want to show the installation process of it, the installation outputs that's found in your console, like download, complete, and so on, then I highly suggest that you have this eval equal false, because you don't want to reinstall these packages. You don't want to have the same output, download is complete, because you might already have these packages already in your RStudio library. So that's the case that you use eval equal false. Another case that is very helpful if you're like loading libraries is the message equal false. Message equal false is, it does not display like, for example, our color brewer is loaded and gplots is loaded. It just only shows this portion, which is library equals our color brewer and library equal gplots, and that's all. That's all to it. Fig show equal hide is to hide your plots. So, for example, if I'm using plots for iris and I want to hide my plot for the final report, then I'll use this scenario, just because maybe I just don't want to show my plots. I just want to show the functions. If your assignments really focus on the commands, the coding itself, but more than outputs that display, then you might need that. And other examples, it might be like include equal false. So it runs your code, but suppress all outputs. This is very helpful for if you're setting up your code. And results equal hide, again, it's more not focused on the plot side of things, but focused on the overall things that has the printed output. So these are just alternate R code blocks. There might be situations that you might need it, and these are very certainly really helpful that you can have in your R code blocks. So like I said again, it's not a definite list of tricks, but it's certainly the most helpful ones possible, and the ones that I use in my report, as you can see as I'm scrolling through it. So that's all for section 3. Certainly, I hope that this section 3 part is kind of like the hook. You might be like, oh man, I'm really tired of going to my R code and just clicking on running all the time and see if it works or not. Or I'm really tired of going my R code and I know a keyboard shortcut of just, command enter, and that's all. But if you're using RMarkdown, then it's certainly more helpful and useful that you can run a specific set of coding. Maybe this code is for printing something out. Maybe this code is for displaying a plot of a pairwise function, but you want to display a plot of a. So that's all for section 3, and moving on to section 4. So before we move on to section 4, all about the iris dataset and in depth about my code while I was working on it, I want to talk about a tip that may not be mentioned in other tutorials about RMarkdown, and that is the outline function. This outline function is found right above console and terminal in jobs. And what it does is, for every header that you create, it develops a specific part in the outline. So header 1 must be the least indented, and header 3 must be the most indented. And you can just go to any part of your code that you want to check out. So let's say I want to go back to section 1. I just click on it, and it'll bring me to a line of section 1. And for every single coding block that you develop, there equates to a specific part that you can check it out. So, for example, what I mean is, let's go to chunk 7. Chunk 7, I label as regression model, and how to label it is just do R, like any other coding chunk, space, and this is the label itself. And that's all. It does not interfere with your output when it generates a PDF or HTML. You won't see it. It's hidden. It's only noticed throughout this code that you see in RStudio only. So it's really awesome because it'll keep yourself organized in what code that you're working on. So I know that this code will be all about regression model, but I can click on here and it could be all about histogram. So another way for RMarkdown to help you in your productivity is to allow you to be organized in your coding. So if you were to work on it, maybe like, for example, for myself, 2020, I'm at 2021. I look at it like a year later, I can know what this code is all about and check it out and sort it out myself and really understand what I did last year. But also you can give it to a friend, you can share it to a friend, and they can check out your code and be a really convenient read for them. So that's all for tips, tricks, and shortcuts for RMarkdown, and I hope that this tip with the outline really interests you for you to work on assignments, projects using RMarkdown, because it does give ways of sharing your code to make it more accessible for anyone who's interested in the information that you're sharing. Let's explore the iris dataset that I use, and I produce this report all on RMarkdown. So there's nothing really flashy about this dataset. For myself, I just want to produce some plots and show you how these plots are produced and how it will look like in a report. So I'm going to show you my keyboard again and running these results. So let's go to library summary and plots here. So the pairwise plot, there's very little information or specific information what this is all about. But from my interpretation and my understanding about it, is that actually this will be like the list of scatter plots combinations available for each variable that's being mapped to each other for being independent. So they're mapped like X and Y's, and there's these different combinations, and within these different combinations, there's these patterns and clusters and different trends these scatter plots produce. So in the case of today, I'm going to explore and I'm going to show you a little bit more in depth about this one here, sepal length and sepal width. Going to map the x of sepal width, x to the y of length, column of length, and x of width. And let's not forget about this part here, these two outliers. You'll notice the similarity between this and the incoming graph below. So this is my regression model. of the scatter plot, and you do notice the two scatter points here, outliers. So I use RColorBrewer to just identify the different species. If you don't know how to use RColorBrewer, then I'm just going to go over just a parameter and talk a little bit more about it. So you just run the library of it first, and then you display all the colors available, or like all the options available. Then palette info will provide information of all possible palette names, and there's just this data frame of everything possible. That's really cool. So I use that option of the palette info, and I select set to. This call will be the color. I'll select the palette set to, and I'll set this colors directly to species, to the species variable. And I also include a regression line. This is the code for it. And yeah, this is the legend. This is the legend code as well. So ColorBrewer helped me a lot because I can identify which species is what, and I can see the different clusters and colors involving it. Setosa is really different compared to Versicolor and Virginica. Clusters do not overlap for Setosas at all. However, it does overlap here. And the trend line, the regression line, is more inclined to be closer to this dataset compared to the Setosa's datasets. So I produced a box plot, general box plot, just looking at simple width of the 3 different iris species. Next is I produced a histogram. The only difference I did for a histogram is that I look at the population density, the density plot of it instead of frequency. However, if you produce it and add into true, then it will count frequency. But in my case, I decided to look at the likeliness in the population of the petal length of all the species of all the 150 samples, and just measure it out and just look at the probability of it, and just look at the skewness as well and visualization of it. And it does produce like this really interesting outlier, but majority of the data is more inclined and skewed towards this way. All right. The heat map is really interesting because what it does is this function is found within R. There's no need to include any packages and anything like that. It's default. Heat map requires a class of data, and this class of data will be inside the matrix, and I'm gonna call a matrix iris heat. This iris heat will be the variable, the number in numerical, the value of the heat map. Scale is how the data is being read, row direction, column direction, however direction. Also has a non-direction as well, which is really cool, really interesting. But CX row and CX column, what it does is provides a scalar of how big the labels are. So bigger number, bigger labels. Call heat colors, just produce the colors. Number is 20, can be any number you like, but I decide 20 amounts of different colors. So row V and col V are in charge responsible of the dendrograms. So dendrograms is like kind of like tree structures that you'll see at the sides of the heat map. But I do not wish to include that, so I put NA, so that will exclude seeing those dendrograms. And I also produce another heat table as well, and this is transpose. So transposing will change the x and y variables and how it's being read. So as you can see, there's a sample number here, but sample number is read as an x, and attributes is read as a y when it's transposed. In transpose, you just flip around the variables. And next is I just added a different version, version 2. And this different version has the color key. And I produce a color key by doing key equal true. Trace is none. Trace I put on row. It will show you the range of cells in different positions, So I don't want to see that in my heat map, so I just avoid that, put none. In margins, just give space between the different spaces of the attributes and samples. All right, so now I developed everything. I have my references. My report is ready to go. I go to knit to PDF. And this is my PDF. It has my header, has everything. Then I go down. See my iris dataset. You see the R code blocks is being represented. See my plots. And then my heat maps. And what I noticed is that the plots is measured first, then the summary table. So I figure it might be in sequential order, or maybe that the plots, since it's the largest output compared to like a table, that it's represented first, that shows up first. So this is what my PDF looks like. And if I want to save it, it varies for different people. There's no like command to like download a PDF, unfortunately. But if you're like me and you have this similar PDF, then you just go up here and you see this file with this down arrow. Click on that, is download. Then for myself, I have Adobe Adobe Acrobat Reader. So I can just open it up through here in my PDF, and I can go to File, Save As, and I save as whatever place I want to save it as, and whatever name I want to call it. So at the very end, you would have this file. In this file, you can use it to submit your project, or you can show your project. You can represent all the data and all the work that you produce. So thank you for listening to my tutorial on RMarkdown. Hope you enjoyed it, and I wish you good luck, and I really hope you utilize this tool available for future work and assignments. All right, take care. Bye.